Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, I'm going to explain the details requirement of the course project. As you can see, the project is divided into two parts, part 1 as well as part 2. And here you need to make sure to submit part 1 on 10 a.m. of April 29 and part 2 on 10 a.m. of May 3rd. It is allowed in here to have a group in this project, and the number of students per group is 4 to 5 students. For the goal of part 1, as listed here, you can see first you have to start with literature review, in which you need to perform research, prepare theoretical background, describe the human hearing. So I want to know what is the frequency range that human can hear within, and then the voice, human voice. So I want you to know what is the frequency range at which the human voice lies in. So I want you to do a research and to know what is the frequency range for both human hearing. So the human can hear, the ear can hear up to what level, what frequency, and the human voice, the chords, vocal cords, can generate voices for human at what frequency range. You should state some scientific ways using literature for audio processing. So search for audio processing and find the ways, scientific ways to distinguish between human voices and background noise. The second objective or goal for part 1 is to prepare voice clips. You should generate signals and noise. So you want to generate signals of noise and human voice. So you have to generate both human voice and signal noise. Then you need to test your hearing with different tones for these noises, and then import into the Matlab those signals, both noise as well as human voices, into Matlab and play those voices inside Matlab to hear them. From Matlab there is some commands where you can play them and hear them. Then you should plot these signals after extracting the data. You should plot these signals in both time domain and frequency domain. And I have provided you with the function that could generate the frequency signal, the Fourier transform of the continuous time signal. So here we're dealing with deterministic signals, which is the noise, and the random signals, which is the voice. After that, we are going to see the goal of part 2. So the part 2 of this project, there are two goals. First, you have to add noise to the signal. So you should process recorded human voice. Here you should add noise with a single tone to recorded voice. Then play and hear and compare between the signal before noise and with the noise. Plot the noisy signal in both time domain again and frequency domain. After that, which is the goal of this entire project, is to filter the voice signal. So voice filtering, and to extract the needed or the wanted signal outside from the entire recorded signal. So just filter out the noise. Here I'm proposing to use a low pass filter. In fact, you can use different types, but here I'm proposing to use low pass filter and to filter out the noise from voice signal. Then play the clips and hear them, compare them, plot filtered signals in both time domain again and frequency domain. Derive the theoretical perspective of mathematical filtering. So here I want you to sketch the filtering operation at frequency domain by your hand. In this project, you have to write a full report for both part 1 and part 2, and this report has to be between 3 to 10 pages. So each group has to submit one full report. The report should include the following sections: the introduction, the methodology that you follow, and the results with a conclusion. Organize your report to show the results and figures for each steps, along with discussion to reflect your understanding. So in the discussion, you have to discuss your results to show your understanding of the code. At the appendix, you should provide the complete Matlab code you have used, attach zip file including voice clips. So I need to have all your voice clips files. After report submission, there will be a meeting per group to discuss the project work. Here, check the Appendix A for some useful links, Appendix B2 and references and Matlab code. And here is some examples. So this is examples given in Matlab code that might be useful for you. And here is some links where you can refer to it to understand more the subject with some reference. So this presentation I prepared for the course project, and in this presentation I'm going to show you some details about the project to make it more clearer, and at the same time I would emphasize on some part of the project to make sure that you get it in the right way. In fact, this is a sample project which you can use to mimic or to follow in order to make the project process much easier. So this is again the course project for the course ELIT 301 in Signal and System, and this is the term 192. As said before, the main goal of this project is human voice application, so it is filtering. In this course, I want you to understand the concept of filtering and in time domain as well as in frequency domain. So this project will connect you to the real life from different perspective, and it will connect you to the different courses in the course and in the applications in the work after your study. So the goal of this project is to process sound signal. So there is a signal of sound, and to see the impact on time and frequency domain. So here we are characterizing the frequency range of human hearing. So this is we're talking about the ear ability, and human voice where we're talking about vocal cord ability. The filter needs to filter out the noise from recorded clips. So if we have recorded sound and we want to filter a noise from it, so this is an application for what we're doing here. Just to remind you, the due date for the first part is April 29 and the second part is May 3rd. Please work in group and submit the report with all different sections. The report should be neat, very important, organized in different sections, number the figures, and so on. Submit your file in one PDF file, your project report with your ID numbers. Now, what I'm expecting from students first is to form a group, and this group could be from 4 to 5 students. Before start, ensure that you install the Matlab full toolbox. Then check the appendices that I provided for you. There are very useful Matlab code, links, references, so do not miss it. This will save you a lot of time. Do not do a literature research, so you have to go and search the net. Search the Google Scholar, search all these literatures for papers or like for textbooks. And when you search, try to find something related to audio processing. So this is one of the keywords that you want to use. Now, this project, the final result of this project is to filter noisy voice clips. So we have a voice clips which has noise, and we want to filter out the noise from it. Then once you're done, you need to submit project report. Now, in preparation, I have laid down these 3 steps for preparation. First, search available resources, and I listed out some of valuable resources: the textbook, mathworks.com, this is for Matlab, and YouTube. You can search for the topics of this audio processing, and you can search also for Matlab tutorials. Second step is all group members should record their voices. So you have to record your voices, and each voice record should be 5 seconds long. So the length of each and every record has to be 5 seconds, and it has to be consistent. And I recommend to do this in the Matlab. Otherwise, you have to truncate these to make sure that it is on the same length in the Matlab. Then compare the results at the last section, discussion section of your report. Okay, then while you're preparing your voice clips, make sure that you have a background noise. What type of background noise? It is either artificial, you can make it up, or it is real. So you can have in background sounds like the one that I've put it for you in the appendix. You can run this file and do your record. And what you need to record is just any sentence like Assalamu alaikum wa rahmatullahi wa barakatuh, or you want to say something good morning, or any sentence. Or you can read, this is a course of signals and systems, whatever sentence you want to make with your own voice. Then I want you to try within your group different type of noises, and here is some examples of the noises. So we can make a background sound of birds, waters, winds, clicks, flips, and etc. This is a list of noises. Report section. So in fact there are 3 main sections of the report, as you can see here. The first one is the introduction. In the introduction, you have to see the theoretical background and the importance of this subject. And there you have to lay down in the background some information about human voice, frequency I'm talking about, characteristics, and the human hearing. So the ability of your cords to generate voices, and the ability to hear with your eyes, ears, whatever type of sounds, so the range of frequencies. Compare the human frequency range with the other voices in the background noise. So if you select the background noise, you just compare this noise with the human voice frequency range. So I want to compare between these 2. In the methodology, which is the main part of your work, I want you to start with putting a diagram, draw a diagram that explains the overall process flow. So what you're doing is filtering. So first you have to show me what are the main steps in a diagram show. So just make a figure of this diagram and show these steps. Ensure to indicate the interconnection between the main steps and show clearly your code reference. So once you're talking about some sections and name it with certain place, explain it in the Matlab code. The Matlab code, I will show something for you, a sample in the next section. Then the last one is just a conclusion. I want to see your observation. What is your observation? And make a conclusion out of your report. You have to put in the appendix your Matlab code. Okay, so this is a sample of the project. You can make use of this, and it will be much easier for you rather than start from scratch. I provided for you a sample code where you can use them and utilize them. So all what you should do is explained over here. Step number 1. So this is the first step. And in this step, I call it hearing test. So this is to check the ability of your ears. So I want you to do a hearing test. And here you want to generate a single frequency signal. And this is nothing but sine or cosine wave. And once you did this generation, you can use sound command in Matlab to hear back the sound of the generated sine wave. Check the example number 1 in the appendix. Please note that laptop hardware can provide sounds in a certain range. So if you cross that range, it will create for you a warning or a message or error message. Then you should test your hearing. Use this generated signal to test your hearing and start changing the audible frequency, the frequency generated, till you see up to what range you can hear. So like start with some frequency F1 and increase till you get F2, and this is after which you cannot hear. So this is the audible frequency range for you. So at the end, for each and every one of the students in the group, they have to put their results in a table and compare this one with the commonly used range for human. So if you look at the literature, you will find a common range for a human being of hearing. So I want you to have a table, and in this table list all the names, and in front of each name the range that he can hear, and then compare the entire table with the commonly stated range of human. In this, you have to plot the generated noise and play them to test your ability of hearing them. This is a Matlab code sample that you can use. Here you can see that this is the frequency that we are testing. Then using this frequency, we have created this noise signal. This is the time axis. And then in this noise signal, we are using this noise signal to plot in time domain. And then I created for you, this is the command to hear, to test and hear the noise and the tone. So then I use this command, I generate this command for you, this m function, and this m function will calculate the Fourier transform for continuous time signal. So once you create it, you will know how does the signal looks like in frequency domain, and if you plot the result, you will get this one. And this is just to do the plotting. In second part, I want you to record your human voice. So in this step, you're going to record your voices. Each group should record voices for all members. These should be done in the background noise. So you should generate some background noise and then record your voices. In Matlab, use record, import, play, and then extract data from these sounds clips. You can use also these commands for further manipulation of these data. You need to plot and play your voices and check link provided in the appendix B. For step 2, here's a Matlab code. In fact, you can see here that there is 2 options. Option number 1, if you have to record. Option number 1, if you have to read from a file. So you have to use these commands to read from files. And option 2, this is option 1, and option 2 is whatever is colored green here. So this is option 2, where you want to record. So this is read from recorded file already, read, and this is for live record while you're using Matlab. based on your options, you go ahead and comment or uncomment these lines. And again, we're using this function which I have provided to you to go from time domain to frequency domain. So this is the time domain of the signal, and this is the frequency domain of the signal. Then the step number 3 is to add the noise. And to add the artificial noise which we created single tone, in this step we add noise which was created in step 1 and voice which was created in step number 2. So step number 1 is addition between step 1 plus step 2. Then I just want to make sure that you pick noise frequency outside your voice frequency range. Do not take it within your frequency range, otherwise you cannot filter it out. Then plot and play this. After you add the noise, you need to hear this clip again and see the effect of adding this noise to it. In this project, calculate, plot continuous time Fourier transform again. So I want you to go from time domain to frequency domain and see how it is affected. This is what I have provided to you to make your life easier. Please note that this function is an approximation of integral. So you have to be very careful working with this. And the signal shape of frequency domain is correct only if sampling was done correctly. You have to sample enough above a threshold. If you go below that threshold, you will not get the right results. Similar for periodic signals, you have to get an elongated time axis to make sure that you get a good results. So these are two important points to be considered while you are going from time domain to frequency domain. And here is a code again for part number 3. So this is simple addition of noise signal plus your voice signal. And this is to hear the voice, and here to go from time domain to frequency domain. Then again, this is the time plot, and this is frequency plot. And you can notice how much distortion your sound has changed with this noise along. And from frequency domain, you can distinguish between your part and the other part of the noise. Now, the last step is to do a filtering. In filtering, you have to design a low-pass filter, and there is another options of using different types of filters, but here I'm proposing to go with low-pass filter. And I want you to design that filter and plot the body plot of the filter. Use these two functions to help you doing this. This is very, very powerful tool in Matlab. So please read about this more. I did not provide you with the code over here. I want you to go and read more. Then the second one is use a filter that you design here to filter out the noise, and then plot the signals and play. So after you filter the noise, you need to play your sound and listen to it and plot your signals and look how it is changed in time and frequency domain. Here you should show if the Matlab results match the theoretical calculation. I want you to do some calculation, sketch whatever things that you think it will happen, and manually just sketch them in frequency domain what will happen between the two signals, the system H as well as the X, the input, and what would expect as Y. And then if these operation of filtering at frequency domain matches whatever it's got in Matlab. So just confirm it if this is right or not. This is the Matlab code without the filter. Filter you have to design it yourself. So this is when we apply the filter. This is we have designed the filter, then we just apply it here. Then this is to hear the signal, and this is to move from time domain to frequency domain. In fact, I give you this figure to show you how I design my filter. You can design your filter with your own things, and this is to plot the following plots. So this is the time domain and frequency domain after applying the filter, and this is to compare between before and after applying the filter. You can see from these two. That's it. Thank you. I think I give you enough details to make your life easier than what you can expect in a normal project, and this will be a very good chance to become familiar with these different types of fields and different type of subjects within the course that we have covered. Thank you so much, and see your results soon. Assalamu alaikum wa rahmatullahi wa barakatuh.